Now this is the actual uh, sort of a diagram that we can remember for those drug dependent or independent reactions. And the hemolysis, this can continue in the case of drug dependent drug independent mechanisms. The hemolysis can continue even after the drug is stopped. So and the antibodies, the drug actually causes the formation of antibodies against the RBC membranes. So the drug and these antibodies, even once the drug is stopped, the antibodies would persist in serum, and they would then bind to the RBC membranes, and they could bind even to non to norm. They could even bind to normal cells. So and these would then react with the RBC membranes, and then cause hemolysis. This is the example of methyl dopa, fludarabine, tridarabine, and other drugs. So and most classically methyl dopa. So and then the drug dependent ones are the ones that would either bind covalently to the RBC membrane, or they would alter the RBC membrane, allowing non-immune protein absorption. So they would so in this case, when in all these cases, the hemolysis requires the continued presence of drugs. So it's, for example, penicillin and cefotetan. Cefotetan was so sort of notorious for this reaction that the that even that it was even taken off the market. So penicillin, however, continues to be used for a wide variety of disorders and prophylaxis. So the drug, it binds covalently to the RBC membranes, and then it causes the epitopes to become antigenic, and this heptin then induces the antibody formation. And then this is another type of a drug dependent mechanism, is when the drug antibody and immune complex, that is the here the drug binds to the RBC membrane first the drug binds to the RBC membrane, and then it causes the antibody to become attached to this complex. Here the drug and the antibody are already complexed in the serum, and they then bind non-covalently to the RBC membrane. So here the drug and antibody complex forms on the RBC membrane. Here the drug and antibody complex is formed in the serum, and then it becomes non-covalently bound to the RBC membrane. This can occur with various CEF triaxones, etc., where they may cause the antibody to be complexed and non-covalently because of some red cell membrane modification methods where it binds non-covalently to the RBC membrane. And then this is the part in which the drug alters it causes modification in the RBC membrane, and allowing non-immune protein absorption. So this is the mechanism followed by clovelinate and cisplatin. Heterophile antibodies. In the case of these heterophile antibodies, they could be either equine preparations because of the preparations of the anti-lymphocyte and the anti-thymocyte globulin that could lead to formation of antibodies against the non-specific antigens. And these heterophile antibodies could then coat the RBC, recipient RBCs, and cause high level of proteins, causing RBCs to spontaneously agglutinate. And in also cases of, there could be human specific like high dose AIHG or hypergammaglobulinemias in case of paraproteinemias. These miscellaneous and non-antibody mediated immunoglobulins could also coat the patient's RBCs and lead to hypergammaglobulinemia. So these were some of the cases that we were doing. And with regard to the drug induced, these type 1, type 2, and type 3, these are very described in this diagram. So this was the one that I was referring to, that when the drug is, so this could be like the drug dependent and the drug independent form. So in the drug independent mechanisms, the hemolysis would continue even after the drug is stopped. And here the drug, it induces the antibodies to be formed, against antigens on the RBC surface. So the drug induces antibodies, autoantibodies against RBC membranes to be formed. And this then this is the autoimmune mechanism, which is the drug independent form, and this can occur in drugs like methyl dopa, phenamic acid, fludarabine, cladribine, and even so we have fludarabine, cladribine, and even uh, procainamide, and so they could be even procainamide and mefenamic acid. So even mefenamic acid can cause this reaction. And then we have a drug, the dependent hemolysis, which requires the continued presence of the drugs, and this drug could bind covalently to the RBC membrane. For example, penicillin and cefotatin. These are these are notorious for binding to the RBC membrane, and this here the drug, it covalently binds to the RBC membrane, and this is the heptin dependent mechanism. So here, a heptin is basically it's basically the heptin mechanism by wherein it's an epitope, but once the RBC combines with the drug, an epitope becomes antigenic because of the heptin formation. And now this drug which is bound to the RBC membrane, this acts as a heptin causing the antibody formation. So this requires actually large doses of penicillin or ciforatin, and so in this case large doses must be used. This drug antibody immune complex, and so then this another mechanism is the immune complex mediated. Here the drug and the antibody immune complex is found in the serum, and it then binds non-covalently. So this binds covalently to the RBC membrane, and this non-covalently binds to the RBC membrane. And this immune complex would occur in the case of quinidine and diclofenic acid and in third generation cephalosporins. So here even very low doses could on second or subsequent exposure could lead to this mechanism of drug induced hemolysis. So very low doses would be required for this drug and antibody complex to become immunogenic. It would bind non-covalently to the RBC membrane, and this immune complex would then cause intravascular hemolysis because it would bind directly to the RBC membrane, and it would cause the activation of the complement. So here the hemolysis would occur due to complement activation. Whereas in this case, the drug independent autoimmune complex, this is only IgG mediated. So this is only IgG mediated, whereas this with the drug and the antibody, they have bound in the serum and then they bind non-covalently with the RBC membrane. Here they cause activation of the complement. So this is only C3 mediated. This is only C3 mediated. This is only IgG mediated. Whereas the one where the drug binds covalently to the RBC membrane and then there is heptin formation, this could cause both IgG and IC3 this could cause hemolysis by both the IgG or C3D pathway, and this would cause extravascular hemolysis. And then and also because this requires the presence of drugs, so this would need the serum reaction for drug monitoring would require the drug treated cells to be present. So the drug treated RBCs are needed to cause this reaction, because these RBCs, these would be the ones that would have that will allow the antibodies to covalently bind to, or non-covalently or covalently bind to the RBC membranes. So these would be the ones that would require, these would be the ones that we need drug-treated RBCs. And in this immune complex mediated also, we would need to incubate the RBC with the drug, or because then only the drug or its metabolite would cause the formation of antibody complex in the serum that would then bind to the RBC membrane. So the eluate in this case would be a non-reactive, because the eluate in itself would not lead to would not cause any antibody formation, would not cause any RBC agglutination. Since it is non-covalently bound, the elevate does not cause agglutination. But only when it is when the serum is tested for these antibodies, with that it would react only in the presence of a drug or its metabolites. And then we have this so this is the autoimmune mechanism, and this is the immune complex mechanism, and then this is the covalent hapten mechanism, and this is the membrane modification mechanism, in which the drug alters the RBC membrane, allowing non-immune protein absorption. So this occurs classically with the spherosporins and the cisplatin and clovelinate, and also with the ribavirin and interferon gamma. So So another point about these autoimmune mechanism is that since the drug produces the antibodies, and then the antibodies they bind to the RBC membrane, so this would actually and so even when the drug has been stopped, these antibodies could cause late reactions. So these could so even with the therapeutic form of the drug, even if the drug is given in therapeutic doses, and even after it is withdrawn, so even after 6 weeks of it would require even after about 6 weeks of therapeutic dose for the antibodies to have reached such a titer that they can cause this IgG mediated extravascular hemolysis. So they would cause IgG mediated extravascular hemolysis. And here the drug could be tested either by a serum reaction. So they could be tested either in the serum or in the eluate. And both of them, in both cases, they would react against normal RBCs also. So because this is specific for the RBC membrane antigens, these antibodies are specific for the RBC membrane antigens, so they would cause a reaction to normal cells, even both the sera and the eluate. Because the antibodies they are present in the serum against these RBC specific antibodies are present in the serum. They would cause a drug reaction against normal RBCs, both in the serum and reaction and in the eluate reaction. It is the ones that become that have the heptane binding. These would they would cause since the drug would then cause reaction only when once it is bound to the RBC membrane. So both the sera and the eluate, they would cause reaction to drug treated cells. So only when the drug has been has been tested, has been incubated against the RBCs, with the RBCs, would those RBCs then now be give a positive reaction with serum and eluate both, uh, so showing a reaction to drug treated cells. So here the serum and the eluate, they show reaction to drug treated cells. Here the serum and the eluate would show reaction to normal RBC membranes. Whereas in the immune complex mechanisms, and both of these would, because these are IgG mediated and these are both IgG and C3d mediated, they would both be extravascular. In the immune complex mechanism, we have the formation of non-covalently binding of these immune complex to the RBC membrane. And so for this case, even very low doses of the drug would be required, and exposure to that would be required. And this would, when once this complex is formed in the serum, so it could be detected in a serum reaction only in the presence of the drug or its metabolite. So only when the drug and its metabolite are present and the antibody is bound to the drug and the metabolite in the serum would then this reaction be positive. And the eluate would then be non-reactive, because if the eluate is tested, then it would not cause any reaction, since it would be eluted off. It is non-covalently bound to the RBC membrane, so it would be eluted off in the eluate. So the eluate would be non-reactive, and only the serum reaction would show a reaction only in the presence of the drug. And this membrane modification, because here also the antibody is alters the drug alters the RBC membrane, allowing non-specific proteins to be absorbed into it. So in this case also, because this also requires the norm, this can also this can occur with into to normal cells. And this part also, where the drug it covalently binds to the membrane, or where it alters the membrane and then causes the attachment of these immune complex. Here both the sera and the eluate would show a positive reaction to drug treated cells. So this is to normal cells and this is to drug-treated cells. These both reactions are against drug-treated cells. And for these, we have a different mechanism. That is, the serum would show reaction to the eluate, or the or only the serum would show reaction to the drug or its metabolite, and the eluate would be non-reactive. And this is the one in which there would be intravascular hemolysis. So we have extravascular hemolysis for both these pathways, and for this one we have intravascular hemolysis. Now the reaction would be affected by the ratio of the serum to cells, and the ratio of serum to cells, we had mentioned that it needs to be around about 2:1 for the reaction to proceed. And generally just 2 drops of the serum and 1 drop of the 5% solution is needed. And when using these cells suspended in saline, it is often advantageous to increase the ratio of the serum. So we can there is 2:1 ratio of cells, and the cells the serum can be actually this ratio can be increased. The serum may be even further added by adding 4 drops of serum with 1 drop of the RBC suspension to in an effort to detect weak antibodies. So for the detection, this is for normal antibodies. They may give a reaction at 2:1. So even normal antibodies, they require a sort of a more of an antibody excess for the reactions to be positive with cells. So for weak antibodies, we can even add we can even increase this up to 4:1 ratio, so that even weak antibodies can show a positive reaction. So then first it would so the factors that can influence the sensitization of cells would be a ratio of serum to cells, or even the reaction medium. So the reaction medium could be albumin, lys, or polyethylene glycol, which is the PEG reagent. And so we'll go through how these affect the reactions. Now both albumin and lys and PEG, these three reagents, they are used in different tests. The macromolecules of albumin allow the antibody-coated cells to come into closer contact with each other. So, how does albumin work? This So how does albumin work? This actually causes the cells to so they haven't actually outlined it, but This is the albumin only because of its molecular structure. The macromolecules of albumin, they allow the antibody coated cells to come into closer contact with each other so that the agglutination occurs. So if albumin was incorporated into the reaction medium, the reaction would consist of 2 drops of serum to 2 drops of 22% bovine albumin and then 1 drop. So we have the same ratio of 2:1 of serum to cells, but to this we add 2 drops of to 22% bovine albumin, and then we can incubate it. Um, uh, we can incubate it to provide the same sensitivity at 30 minutes of incubation as a 60-minute saline only test. So for saline, we had 1 hour incubation, but and this in case of albumin, we would need to incubate it for 30 minutes. That this albumin technique may miss several clinically significant antibodies. Therefore, it is rarely, if ever, used in as an IAT medium for routine test. So, because many clinically significant antibodies may be missed, so this is a disadvantage of albumin testing, that many clinically significant antibodies may be missed by this technique. Therefore, it is rarely, if ever, used in IAT medium for routine tests. And now the lists and the peg are the ones that are more routinely used. Albumin is okay, the only disadvantage. The disadvantage with albumin is that it can miss clinically significant antibodies. And one of the techniques, I think I will go through this, is that albumin actually causes aggregation. This is, and the albumin that is used is this 22% bovine albumin. This is 22% bovine albumin, because 4% albumin is isosmotic and 22% is hypoosmotic with human serum. And this bovine serum albumin, what it does is that this actually allows them to come into closer contact because it decreases the zeta potential. So this was something that I needed to look up. It decreases the zeta potential of RBCs, and therefore it causes them and it excludes the water from the serum. So it excludes water and it decreases the zeta potential. Therefore, it allows the macromolecules, it allows the RBCs to come into closer contact, the antibody-coated RBCs to come into closer contact with one another. Then this list which is used is this is actually a glycine in an albumin solution. So list, the low ionic strength saline is actually a glycine in an low ionic strength solution. It's not low ionic strength saline, it's low ionic strength solution, which is actually glycine in albumin solution. So this needed 30 minutes incubation with albumin, but with less we need just 10 to 15 minutes incubation. So albumin actually increased the dielectric constant of the medium. That is, it decreases the zeta potential, and therefore it caused the non-specific so that therefore it actually it could miss clinically, but its disadvantage was that it could miss clinically significant antibodies. With low ionic strength saline, the LIS medium, it actually causes the decreases the charge. So LIS decreases the charge, and so all these actually reagents, they cause some effect in the solution. That is, albumin decreases the zeta potential. LIS, it decreases the charge, the surface charge. LIS also contains some macromolecules. They mentioned that LIS also contains some LIS also contains macromolecular substances. and this list would reduce the zeta potential surrounding the RBCs. This would also decrease the zeta potential, and it is because since this also contains macromolecules, since this is also glycine in albumin solution. So this would also decrease the zeta potential, and another thing that list does it that it decreases the charge also. So this is same as decreasing the zeta potential, and the list technique introduced has critical requirements with respect to the serum to cell ratio. So optimum conditions for this also we need 2 drops of serum and 2 drops of 3% suspension of cell in this. Increasing the serum to cell ratio increased the ionic strength of the reaction mixture, leading to a decrease in sensitivity and counteracting the shortened incubation time of the test. So a list medium may be achieved by either suspending RBCs in this or using a list additive reagent, with the latter being the most common practices that list is used as an additive reagent. And then when you are suspending the RBCs in list, then this the reaction mixture with the 3% reaction mixture would be used in a 2 to 2 cell is to serum ratio, serum is to cell ratio. So for PEG, we have it is a water soluble linear polymer and is used as an additive to increase the antibody uptake. Its action is to remove the water molecules surrounding the RBC. So basically what it does is LIS and albumin, they actually decrease the zeta potential, decrease the charge on the surface of the cells. They allow these macromolecules. LIS is actually sort of uh, albumin is bovine serum albumin, that's 22%, and it is hypoosmotic with the human sera, and therefore it causes the it causes the agglutination reaction to occur within about the 30 minutes. So with the list that this also decreases the zeta potential. It's macromolecule that causes the cells to move closer together, and it decreases the incubation time from from 30 to 60 minutes to 10 to 15 minutes by reducing the zeta. So apart from albumin, once low glycine is added, so it becomes a low ionic strength solution, and it further decreases the time for incubation from 10 to 15 minutes. And in this case, we add 2 drops of serum to an RBC suspension in list, then we need to add 2 drops of serum to 2 drops of cells in cell suspension. And otherwise, we can add list as an additive reagent. And in that case, also we need to add 2 drops of this